Okay, so good afternoon, everyone. Good morning or good afternoon, no, to the sections who will be doing this activity today, no, or next time, no. But I'm going to present to you, no, the third experiment, experiment number 3, which is the free falling body, no, or others just simply call this as free fall, no. Now, our objective now for this activity is to determine the acceleration due to gravity, and we know the value of this acceleration due to gravity. No, it is a kind of a constant value. There's an accepted value to this one. No? But what we will calculate today or perform today is the experimental value of this g. No, so now, the materials that are needed now, please take note of the materials that are needed. No? So, the tennis ball, a timer, a meter stick, and maybe a chalk, no? Or any kind of a marker. No? So, if you don't have a meter stick, you can use some other measuring tools. No? But it has to be expressed in some kind of a unit, meter or centimeter. No? Timer or stopwatch, no? Like the one that you found in your calculator or cell phone, and a tennis ball or any equivalent rubber ball, no, that you can use for dropping. No? So these are our materials. And moving on now, here's the procedure basically. So we are to gather the following materials. So there are 4 suggested materials here. No? A timer, a tennis ball, a piece of chalk, and a meter stick. No? Now, we are to prepare, no, the meter stick and the chalk, guys. No? And we are to next, no, mark the wall, no, that you have in your house. Maybe you locate some kind of a wall there, and you are to specify some markings on the wall, no. So you are to mark heights, no 1.5 meters, 2.25 meters, and 3 meters, no, on the wall, no. So maybe you get your chalk, and then you mark the walls, no, according to the specified lengths, no. And again, that's the purpose of your chalk. No? So maybe from the baseline of the floor, you can set, no, the meter stick. No? Now, again, now with this given heights, guys, no, you are going to prepare or get your tennis ball and place them one after the other, no, on each of these heights. No? So we will start at the very bottom height, no, of 1.5 meters na mark, no? And position our ball there. No? So holding the ball with your left hand, you will also ready your right hand, no, for the stopwatch. And then now you can position the tennis ball, no, with your left hand, and then with your right hand, no, you can prepare the timer, no, and set it to 0. No? Now you can let next the ball to fall down. No? And then make sure that you also, no, synchronize the stopwatch. Once the ball reaches the floor, then you stop the time. No? So the time starts when it leaves your hand, and then it stops when it reaches the floor. No? Now, you record the time there, no, and you do the process maybe 3 times, no, or 2 more times. No? So you get the time, no, in seconds and record the time in the table that you have. No? Then next you go to the 2.25 meters na height, and then you can do the same process and record. No? So you repeat this 3 times. No? And the next is to go to the 3-meter height and then do the same thing. No? So 3 times we are going to do that. And here's our way of recording, no, the time. So the time for our first trial or our first activity. So you will record 3 different values of time there, no, by repeating the process for 3 separate trials. No? So that's for the height, no, 1.5 meters. A separate recording is done for the 2.25 meters. And again, now you are going to get the three values of time here, granting that they are different. You're going to get one single average time for these three trials. No? So you will get one average time of fall for these three observations. No? The same is true for this one. And then the last column there is to calculate the value of G. No? So the experimental value of G will be based on some kind of an equation, no? Based on our free falling body. No? So these three values, no, again, of our time is taken, no, one single value now and converted into an average time. No? And using this value here, we will plot it or plug it, no, to our formula in calculating the experimental value of G. No? Now, our experimental value of G, guys, no, is determined, no, by using our expression, no, that is twice of the height, and again, now divide by the value of t squared. No, that's how our height, no, that's our G value, I mean, is determined. No? So again, now for our value of G, which I kind of miss here, no? So G is equivalent to, so the experimental value of G is determined as equals to G equals to 2H, no? H being the value, no, nga amo tong 1.5, no, meters, the 2.25 meters, and the 3-meter height. No? So that's the value of H. And then you divide that by the corresponding average time T, no? And you square that time T. No? So it has to be kind of squared. No? So this is how we get the value of our acceleration, or this is the experimental, no, value of our acceleration G. No? So experimental value of G. No? So again, now from the table that we had, no, we see that again, now we see that we can, no, we can actually have, no, uh, three values of this experimental G. No? So this is the first height. No? Then there's another experimental value of G. No? So for the summary table, you are to write all these experimental values of G and get its average value. No? Now, based on the average value, this is where we get the percent difference. No? And the percent difference, again, is the average G minus the accepted G value divided by the accepted value. No? So again, there's a summary table wherein you can write the average G value. So one value being at 1.5, one value at 2.25, no, and then 3 meters, no. So you have to get one single value to compare it with the accepted value. Now, what's our accepted value of G? It's equals to 9.8 or 9.81, no, meters per second square. No? Okay, now here is our table. So if we are to use our table, can you see this page? So this is our template. No? The table that we saw now was taken from here as well. No? So please take note of our objective and the parts of your experiment. No? So basically, that's the experiment that we'll be having, no, for this one. No?